Hey everyone. Today I would like to present my research under Sikkim Research Grant 2020 and 21. My research is sponsored by Simeo Kitab in Mathematics. Here is my research title: Improving Secondary Students' Mathematical Literacy under Fishing Trap Theme through a 4D frame assisted STEAM activities in the problem-based instruction. I am the leader, Shakti Pradana, and I'm working with my partner, Mr. Tumar Sansihole. And this is our background. Indonesia, as we know, that one of the lowest PISA score. Yeah, we are in the rank 70 and 70 out of 77 in 2018 based on the OECD 2019. So that was some 28% of students in Indonesia attain level 2 or higher based on the OECD average is 76%, while around 1% only of the students score at level 5 or higher in mathematics. The OECD average is 11% based on the OECD report in 2019. As we know that a student that reach a level 2 is only capable to solve the simple task, simple question by only applying the formula into the familiar context. Yeah, from this problem, we need to find the alternative how we change the learning environment in order to increase the student mathematical literacy. So that's why we are looking for another alternative. The alternative is the use of STEAM learning has a great potential in this case. So when we are reviewing the literature, the use of STEAM learning has a great potential to improve thinking skill, learning outcomes, spatial abilities, motivation, and changing student attitude toward STEAM and STEAM career based on the previous studies. Yeah, while there are still few in number that the STEAM research has focused on mathematics field. So that's why this is great opportunities to us how we can use STEAM learning in order to increase the student mathematical literacy. As we know that one of mode of STEAM integration in learning suggested by Stallman is by focusing an open-ended problem through engineering design challenge. So now we need to collaborate, we need to combine this STEM learning activities, okay, STEM learning and STEM activities into the familiar and powerful learning model. In this case, we chose the problem-based learning. Why? Because the nature of STEM is very compatible with the PBL model. The flexible nature of 4D frame, which can form spatial formation, support the engineering design challenge. Why? What is the 4D frames? Well, 4D frames is the tool that we are going to use to facilitate the problem-based learning. In this problem-based learning, we are using the learning theme, a traditional technology that we call it as BUBU, as a fishing trap. So the student in the problem-based learning instruction need to construct and model this traditional technology called BUBU in Indonesia to be the BUBU model by using the 4D frame. The 4D frame has a flexible nature that can form spatial formation, and it support the engineering design challenge in our case. So that's why improving student mathematical literacy through 4D frame assisted STEM activities is really possible to do. Okay. Now, this is our research question. Okay. Apart from the PISA assessment in mathematics still place Indonesia below the average score While we know learning demands is growing faster, STEM learning then became a promising new trend and began to be used to meet this demand. But unfortunately, the current research related to the use of the STEM research in collaboration with reliable learning model, such as problem-based learning to improve the mathematical literacy, they are still few in number. So this is a great opportunity. Therefore, the study has been designed to investigate the answer to the following question. One, what is the student mathematical literacy in our school? Two, what is the effect of problem-based learning with a 4D frame assisted STEAM approach on student mathematical literacy in the theme of phishing trap? Yeah. Yeah, we are using the framework of PISA, especially in mathematics. As we know, mathematics has two domains, content domain and competence domain, process domain. Yeah. In this case, in this study, we are using shape and space as our mathematic content, while for the mathematic process, for the mathematic process and competence, we are using the framework of PISA 2015 and 2018. Yeah, so the student need to formulate, need to interpret, and need to employ mathematical concept in here. Okay, you may see in the right side is the various type of the phishing trap Bubu. Yeah, not only in Indonesia, actually, this phishing trap is around, it can be found around the world. Yeah, okay. From the picture, we can see that the shape and the design of the phishing trap can facilitate our design challenge because what? Because so many shape that can be used uh, to build, yeah, to build from the cylinder, from the cube, and from the prism, and from the cylinder. Yeah, so that's really interesting. Will be interesting, yeah, for the students to build this design. Yeah, if we are breaking down the each component of the STEAM, science, technology, engineering, art, and mathematics, I can explain that science in this activity, the student have to demonstrate of working understanding of density, buoyant force, the ecosystem. Okay, while for the technology used, yeah, we use a 4D frames is a powerful technology, powerful tool that can cover and facilitate 3D dimension challenge. Yeah, while for that we can also use GeoGebra as the pre-design process before they construct directly the model by using a 4D frame, so they need to design by using a GeoGebra. While for the engineering in this case, is demonstrated with each group giving the same material for the frame kit, if possible, for the frame kit, or maybe they can use the other alternatives. Yeah, but the same material, they are designing and constructing different model of fishing trap, and they need to solve a given problem, how to create the base design of fishing trap, and how to get the design that's effectively used to capture the fishing, the fishes, crabs or shrimp. Yeah, not only fish. Yeah, actually, this art. The art aspect is to realize that which each group create the design of the fishing trap as a product which are going to market. Students need to consider how their design work so the customer are willing to pay more for product due to its design look and feel better than other groups' product. While for mathematics, as we know, each group need to perform and validate calculation of how many materials they need in construction process, how big a volume of the trap they can construct with specification of given material, and major purpose set by all group is to create the volume of the trap that can hold a lot of fish by considering the geometry of the trap. Students have to be able to calculate the volume bounded by the trap. So they, in the learning process, they need to learn about the formula of the volume for example, the cylinder, the cuboid, prism, okay, and how they apply in the context of the fishing trap. Okay, considering the current situation during pandemic, yeah, so pre-experiment with one group pretest posters design with things really reasonable to be used, yeah, during this pandemic. So we only need to engage middle secondary students, grade 8, two classes in our school as the sample, okay, as the sample, convenient sample, and we engage them to join with this research. While for the use of collecting, for the purpose of collecting data, we create an instrument that we call as mathematical literacy test, and to know their response, the student response after learning process. So we need to create a student response toward the STEM activities. Yeah. Okay. All 8-year students in academic year 2021-22 or junior high at Global Prestasi is as the targeted population. Yeah. The study sample from the accessible population is sample convenience, as I was mentioning before. Yeah. So after we collect the data, pre-test and post-test, we are going to analyze the data by using the formula that proposed by Haig. Yeah, this is the normalized gain formula, or it's proposed by Labo is normalized change. Yeah, okay, the same as the same as with Haig, but actually it can be general. Marx and Cumming proposed in the 2007. Normalized change is the final score minus minus initial score divided by the maximum possible score they can reach. Yeah. So the interval is high, medium, and poor. Yeah. Yeah. This analysis is designed to answer our hypothesis. The hypothesis is the design learning, okay, by using the problem-based instruction with the 4D assisted problem instruction in the STEM, by using STEM activities. Okay, by using STEM activities can be categorized as the active learning if, okay, we get the normalized change, average normalized change around 40% in this case, yeah, or 0.5 in this interval. So that's why we hope this analysis, this research can be managed well. And this is the sample design that we has constructed by using a 4D frame at the right side. Yeah, this is the 4D frame in the right side, and for the left diagram we are using the magic straw. Yeah, because in this pandemic we cannot provide the student with the 4D frame directly, yeah, because yeah, we are working at home right now. This is the sample of the test that we have constructed. Yeah, question intent mathematical process, of course. Yeah, the process is employing mathematical concept, right? Procedure, reasoning. Okay, that's all. Thank you for listening to my explanation and my presentation, and thank you for watching. Yeah.